Now that we learned about the left and right inverse, we're going to begin a very simple example for you. In this example, I want to show you that the identity matrix, a 2 by 2 identity matrix, is going to be the inverse of itself. To show that A and B are inverse of each other, you basically need to show that the multiplication of A and B is the same as the multiplication of B and A, and both of them gives you identity matrix. Remember how we defined the multiplication of two matrices. To multiply two matrices, you start by taking the first row, multiplied by the first column, you basically find the dot product, and you continue the process. If I multiply A and B together, I'm basically taking the identity matrix and multiply it by itself. So here you have 1, 0, dot product with 1 and 0. The result is going to be 1. Just simple algebra, everybody. Then you move on to the second column, 1 and 0 times the second column, which gives you 1 times 0 plus 0 times 1, which is basically 0. Then on the second row, you have 0 and 1. Multiply that by the first row, first column, which is 0, 1 plus 1, 0, which is going to be 0 again. And then the last column is 0 and 1. So 0, 1 multiplied by 0 and 1 is going to be 0 times 0 plus 1 times 1, which gives you basically 1. Hey, I got the identity matrix. So far, the multiplication of A and B is identity matrix. Now find B times A. Well, the process is the same because these two matrices are the same thing. It means that if we do the multiplication, the result is going to be the identity matrix. So we just showed that AB is equal to BA, which is equal to identity matrix. What's the meaning of that? It means that A and B are inverse of each other. Or you can say that, hey, the identity matrix is invertible.